Pre-statistics. Introduction to Functions, Part 3. Lesson Objectives. Determine the important characteristics of a function. If you recall from the last video, we talked about interval notation, and when we have an open parentheses, that means the value is not included, or it's what is called open. If we have a bracket, that means the value is included, or another way we can say that is it's closed. So here we have the different cases for interval notation and how it relates to inequality notations and the graphs. So if you need some additional examples, please pause this video and look over each example. Finding the domain and range of a function. When we are asked to find the domain and range of a function, we need to remember what the domain relates to and what the range relates to. So in alphabetical order, X comes before Y, and D for domain comes before R for range. So this is an easy way to remember that the domain is the X values and the range is the Y values. So for this example, our X's, all possible values of X, is our domain. We think of this as a pencil where it crosses the x-axis to the first point, and then we move this along, and all these x's will have a spot on this graph until we get to the end. So the domain would be 1.5 all the way up to 5.5. Now when we do the range, again we are thinking about the y values, so we draw a straight line to where it touches the smallest y, and then we keep moving up the y-axis until we get to the largest, and these are the possible values of the y. So the range would be all y values from 1 to 3. Obtaining information from graphs. A closed dot indicates that the graph does not extend beyond this point and the point belongs to the graph. An open dot indicates that the graph does not extend beyond this point and the point does not belong to the graph. An arrow indicates that the graph extends indefinitely in the direction in which the arrow points. Let's do an example. Example 10. Use the graph of the function to determine the function's domain and range. So for number 1, we are going to think of this as a pencil, and we're going to scoot along this graph, and we want to know what x values touch this graph. So as we move this pencil across, we saw that the first x was -4, and all these x's had a spot on the graph until we got to x equals 5. At x equals 5, that was the last point, so anything beyond that is not in the domain. So to write this domain, we would say -4. Since that's a closed circle, it can equal it. Same way with +5, it can equal 5. We want all numbers in between these two. So inequalities, we would write -4 is less than or equal to x, which is less than or equal to 5. In interval notation, we say bracket -4, comma, +5, bracket. Now for the range, we go to the y-axis. We think of this as a pencil, and we're going to move to all the y values. So what values were covered? Well, the first time this hit a y was when y is equal to -3, and all these y values up to when y equals 4. So any values beyond 4 will not be in the range. To write this, we would say -3 is the minimum, the largest is +4. We want all y values, and because they're closed circles, they can equal 2. Notation, bracket -3, comma, positive 4 bracket. For number 2, the domain, we take our pencil and we slide it across the x-axis. Because this arrow is going on forever, all these x values will have a place on the graph, and on the right hand side the arrow is going in this direction, so all these x's going in this direction will have a spot on this graph. Since all x's have a spot on this graph, the answer is all real numbers. So we can write it like this. We could write it from negative infinity to a positive infinity. We don't put equal signs because we can never equal negative infinity or positive infinity. In interval notation, we say negative infinity, comma, positive infinity. And again, we use parentheses. For the range, we slide our pencil on the y-axis, and we want to see where does this pencil cross the graph for the y's. The pencil first intersected at negative 3, and then it had y values all the way up, and since these are arrows, this is going up to positive infinity. So the way we write this, smallest y was negative 3. It can equal that. The largest is positive infinity. So since it can equal negative 3, we do this. Now another way of writing this is saying negative 3 is less than or equal to y, which is less than positive infinity. Everything's less than positive infinity, so we really don't need this. So we could just say as long as y is greater than or equal to negative 3. So if you think about it, this is saying all y values that are larger than negative 3. In interval notation, we would write negative 3 bracket, comma, infinity, parenthesis. Increase in functions. If a curve goes upward from left to right, we say that the curve is increasing. When the graph of a function is increasing, we say that the function is increasing. Decreasing functions. If the curve goes downward from left to right, we say that the curve is decreasing. When the graph of a function is decreasing, we say that the function is decreasing. So the thing to keep in mind about increasing and decreasing functions, if the function's increasing, it has a positive slope. If the function's decreasing, it has a negative slope. So here's an example of a function that has increasing parts and decreasing parts. It's a good idea to pay close attention to these values here because these are the turning points, which means where it changes from decreasing to increasing. And at this point it goes from increasing to decreasing. And from this point it goes from decreasing to increasing. So when we talk about increasing and decreasing functions, we want to know what x's are producing the part of the graph where it is increasing or decreasing. Since we want to know the x values, we take our pencil, we line it up to the x-axis, and then we move our pencil along until we hit the turning point. So from negative infinity up to this value, that's decreasing. So that's one section. Now the next section, we take our pencil and we move along until we hit the turning point. So from this point to this point, that was increasing. Next, we move to the next turning point. So from 0 to 1, that's decreasing. And then finally, from 1 to positive infinity, that is increasing. So for this function, we had two areas that were decreasing, we had two areas that were increasing. Let's do an example. Example 11. Use the graph of the function to determine where the function's increasing and decreasing. Number 1, this is decreasing. Then from this turning point all the way to this turning point, that's increasing. Then from this point down to this point, that's decreasing. So for this one, we would say from negative 2 to a positive 2. all x values there were increasing. We don't put equal signs here because at this point it's neither increasing or decreasing, and at this point it's neither increasing or decreasing. We're never going to have equal signs here when we talk about increasing or decreasing function. An interval notation, parenthesis, -2, comma, +2, parenthesis. Okay, where is this decreasing? Well, that is from starting at -4 all the way to our turning point here, which is at -2. So x is between -4 to -2. We also have this section over here, and this is going from when x is 2 to x is 5. So decreasing to write these two would be -4 to a -2, and from a +2 to a +5. That's decreasing. Interval notation, -4 to a -2, and from +2, +5. Number 2, where is this graph increasing and decreasing? So from -infinity, because we have our arrows, all the way up to this point, that's when x is 1. So we have from -infinity up to 1. Again, we don't use equal signs here. This is saying -infinity is less than x, which is less than 1. That is equivalent, because everything's less than -infinity, to just saying x is less than 1. So when your x value is less than 1, this function is decreasing. In interval notation, parenthesis, -infinity, comma, 1, parenthesis. Where this graph is increasing, we have our pencil here at +1, and if we move it along in this direction to +infinity, the graph is increasing. So we would write that as beginning at 1 up to +infinity. This is our notation, and of course this is equivalent to x is greater than 1. And interval notation, parenthesis, 1, comma, +infinity, parenthesis. Thanks for watching.